Hey everybody, so welcome to physics and welcome to your first video of the year. So today I'd like to introduce you to what I call the big four. All right. Now we talked about the idea that in this class we're going to be looking at something we call classical physics, right? The idea of classical physics is that you can gather data and you can gather enough data that you can either predict what's going to happen later or you can figure out what happened before right now. And so that's the big idea of classical physics. Now, a couple of things that you may have learned in your math class. The first thing is you may have learned about something called functions, right? And a function is you have an x value, and when you put a value in for the x value, then you can get a value out for the y value, right? So you learned about these things called functions. Now, that's oddly very much like what we're talking about here, right? We're saying we have enough information that given some data, we can predict what's going to happen later. If we have an x, we can figure out what's going to happen to y. Functions, right? Now with functions, you then attached it to various things. You created tables, you created equations, you created graphs. And so today, I want to connect that idea of graphs and tables and functions, equations, to what I call the big four. Now these are the four most common relationships that we're going to see in this physics class. Is it possible in physics to see other relationships? Absolutely, and we may see some of those this year. But the four that I'm going to show you right now are the big four, the four that are going to be 95, 99% of what you're going to see this year. All right, so here we go. These are all about relationships, functions. How is one thing related to another? Now, the first one that we're going to look at is the simplest, and that's linear. All right, so you should be pretty comfortable with a linear equation. As one variable increases, the other one increases, or you could have something where this one is increasing and the y value is decreasing. You've seen that variety of things in Algebra 1, maybe some of your other math classes. But we've got linear. Now, with that, we have an equation. Now, the equation is always going to relate x and y. Most of what we see is going to go through the origin, right? It just makes sense that if we're looking at distance versus time, after 0 time, it's traveled 0 distance. If we're filling up a beaker of water with water drops that are dripping, it makes sense that after 0 time, there's 0 milliliters of water in that container. Now, is it possible to have y-intercepts? Yeah, of course, but most of the time, we're going to have graphs that go through the origin, especially with the data that we're collecting. All right, now the equation, there you go. So we've got y, which is our dependent variable, the one we're trying to predict, is equal to some value, some constant, times x. Now you probably learned in math class that that constant is the slope. We're going to use that this year. All right, it's going to be important. Slopes and areas are actually going to be really, really important as we get deeper into the physics and motion and forces and things like that. Okay, I did add on the plus b, but to be honest, again, most of the time, that plus b is going to be 0. And so it's going to look something like just that, y equals kx. And if we can find out what k is, if we can find out what the slope is, that will tell us something significant about the situation that we have. All right, so that's our first of the big four, linear. Okay, now the second one is quadratic. So you can tell that I've only drawn the right side of the quadratic. This is, you might see the whole thing. You could see an upside down or a concave down quadratic as well. But for now, we're just going to go with the basic quadratic that as x increases, y has a squared or quadratic relationship. Now, again, we have an equation, a base equation for a quadratic, and that is this. All right, now you may say, well, that's a lot easier than the quadratics I learned in Algebra 1. Well, yeah, we're going to probably be going through the origin. Just like we talked about here, a lot of the time, that 0x is going to result in 0y. And if that's the case, we go through the origin, we end up not having those other two terms. All right, so most of the time, we're going to try to keep it pretty simple and straightforward. To be honest, nature tends to be simple and straightforward. Nature doesn't want to follow some big complex process or equation as it's going through whatever naturally happens. Nature's pretty straightforward, and you should be able to figure out most of the time a pretty simple pattern as to why something is happening the way that it is. All right? Now, the other two graphs are very, very similar to each other. Now, these you may have seen or you may not have seen before. All right? So let me go ahead and put those two up. All right, so inverse and inverse squared. These are the other two that we see quite often, right? Now, in inverse, you can tell that as the x gets bigger, the y gets smaller, but it's not a linear relationship, right? There's something else going on there that causes it not to be linear, not just a negative linear slope. It actually has some kind of curve like this. Now, this end will get closer and closer and closer to the axis, but it won't ever get there. You may have learned about that as an asymptote. If you learned about exponential functions in math class, you probably learned about asymptotes. All right, so this will get closer and closer, but not ever get there. That should make sense in the equation down here. As x gets bigger and bigger and bigger, then you'll do 1 divided by that, and 1 divided by a big number is going to be small, and you'll just keep getting smaller and smaller and smaller, but you can't ever get negative. Can't ever get to 0. So that makes sense with what we got here. Now, you'll look at inverse squared and say, well, that looks somewhat similar. And I have exaggerated a little bit here, so it's a little bit easier to tell the difference between the two. Notice that on the end, it's a little bit more vertical, and over on the end here, it's a little more horizontal. Again, it's never going to reach 0, but it will flatten out a little bit sooner. You can also tell that the curve here is a little bit sharper, okay? Now, there are other ways that we can tell the difference and that we can prove whether a graph is inverse or inverse squared, and I'll learn you about that later. All right, so I'll teach you about how to decide the difference between those later. But the big thing is, we want in this course, as we're trying to study this idea of classical physics, we want to be able to find the relationship between different variables. And so we're going to go ahead and we're going to learn about these four for sure, because they're the most common ones. If you go on to AP, you're going to see a lot more relationships, especially in AP Physics 2. In this class, like I say, these are a pretty good start. All right, so for now, I just want you to get comfortable with the idea that we have 4 different types. Get comfortable with their names, get comfortable with their equations, and if you can do that, then we are good to go for now. All right, see you in class.